All right, this is systems day 3, which are nonlinear systems. Okay, so we have totally been focused on two equations of two lines, finding where they intersect, finding out that they're parallel and they don't touch, or finding out that they are on top of each other and they are the same line. So now we're going to move into something where it's not linear, which means curved surfaces. And we're mainly going to focus with the x squared, your parabola, the one that you're really familiar with. So these types of systems have at least one equation that is not linear. So not a line, meaning it's not straight. And these types of systems can have 0, 1, or 2 solutions. And what I mean by that is, let's just say we had our parabola. I could hit the parabola twice. That's how I would get 2 solutions. I could hit the parabola 1 time, or I could hit it 0 times. So you could have 0, 1, or 2 solutions depending. This means that we're going to be doing a lot of factoring, and we're going to be doing the quadratic formula. So I'm going to write it here for you in case you don't have it. And I have a program that does the quadratic formula for you in your TI graphing calculator. So if you bring it to me, I'll help you get the program. So I've got 4 examples for you to try. First one says find the solution to the system. So since we don't have anything we can substitute yet, I'm going to kind of do what we did by substitution. I'm going to take this bottom equation off to the side, and I'm going to solve for y. And I'm picking y over x because if I solve for x, I have to eventually divide by 2, and that means introducing some fractions, which I'm not really interested in. So I'm going to solve for y instead. So if I move y to the other side and 1 comes over here, I'll have 2x plus 1 equals y. Oops, my lights just went out. And then I'm going to take that and plug it into my top equation for y. So I've got 3x squared plus 4x minus, and make sure you protect it with parentheses because that negative has to go to all of it. 3x squared plus 4x minus 2x minus 2. And then I've got 3x squared plus 2x minus 2 equals 7. Now before you can do any solving, quadratic, or factoring, you have to make sure that your equation is equal to 0. So we actually need to move that 7 over. My bad. This is a 1 here. I got really excited. A negative times a 1 is still negative 1. I think I was timesing by 2 in my head. So when I minus that 7 over, I'll get negative 8 equals 0. So in order for you to factor or quadratic, you might want to write that down, you have to be equal to 0 before you can do either. And factoring and quadratic formula are the only ways for you to solve for a squared. So that's what we're going to do next. This one doesn't factor really easily, so I'm going to use my quadratic formula program, which again I can give to you. Just bring your calculator into me. So I've got a 3, and then I've got a 2, and then I've got a negative 8. So it looks like my two x's are 1.3 repeating and negative 2. Whoops, 1.3 repeating and negative 2. And then I will take them and plug them back in right here. So negative 2 times 2 is negative 4 plus 1 is negative 3. And then I'll put 1.3 repeating right there. And I end up getting 11/3, which is also 3.6 repeating. So those are my 2 solutions there. So it looks like our parabola got hit by the line twice. Next one I've got kind of the same setup. I'm going to take the bottom equation. I'm going to solve it not for y because I don't have any y's up there. I'm going to solve it for x instead. Oh, wait a minute. Oh, this is supposed to be, oh, I hope yours says y right here. That's my typo. I didn't mean for that to be 0. Hopefully your notes say y right there. So I'm going to take this one off to the side, and you're darn right I'm going to solve for y. So y equals 1 minus 7x. And now we're going to plug that in right there. So 3x squared minus x plus 4 equals 1 minus 7x. Just getting everything over to one side. Will give me a plus 6x and then 3. Using my quadratic formula program again. Using a 3, a 6, and a 3 gives me, it's the same root repeated, so I just only have to do it one time. And then plugging negative 1 back in, negative 7 times negative 1 is 8, plus 1 is negative 1 times 7 is 7, plus 1 is 8. 2 more to go. This is again a parabola, and we can pick hopefully the top equation we want to solve and then plug it in down here. So I'll take this off to the side, solve for y, and then we'll plug it in. So just simplifying, doing a little rearranging, I'll put the x next, and then if I minus 3, I get a plus 1. So when I go to do my quadratic formula, I have a 1 and a 1 and a 1. And then I'm going to get an error, and it didn't like that. Okay, so let's see what's going on here. So I'll do the quadratic formula quick by hand just so you can see. So I've got a negative 1 plus or minus 1 squared minus 4 times 1 times 1 all over 2 times 1. Lots of 1s. Negative 1 plus or minus square root of, I've got 1. 4 times 1 times 1 is 4 over 2. Here's my problem. 1 minus 4 is negative 3, and you cannot root a negative. So that's why your calculator is telling you error, because it can't root a negative. And so that means that this system has no solutions. Last one, I'm going to take that top equation and I am going to solve for y. So moving the y over and then bringing the bringing the 1 back with the x. I'll plug that in for y and get x minus 1 squared equals 25. We should talk about how being squared means that there are 2 of them and you're going to FOIL them out. What it does not mean, what you might want to write in your notes, this is not x squared plus 1. You do not get to distribute a power. That's not how that works. So make sure that you write it twice, because we're going to need to FOIL that out. And then combining like terms and bringing my 25 over, I'll have 2x squared minus 2x and then minus 24. So I can quadratic formula that. I've got a 2, a negative 2, and a negative 24. So my 2 roots are 4 and negative 3. And then I just have to plug them back in. So 4 minus 1 is 3, and negative 3 minus 1 is negative 4. So not really much different in terms of what we've been doing to these ones. They just are going to need the quadratic formula or factoring in the end because you're dealing with a quadratic.